All right, let's see. Y'all should have this factored by now. It's just a handsome little quadratic trinomial. Um, what's the first step here in factoring? Let's say before we even factor, we should size it up. Shouldn't we do a little housekeeping, as I said yesterday? Make sure that it's written in standard form, in descending order degree. Is it? Yeah, yeah. Okay, now that we're ready to factor because it's in standard form, the first rule of factoring is never, not always, to always look for a what first? Common factor. Good. GCF. Do we have one? No. Okay. So it's a quadratic trinomial, so it could factor into a double bubble scenario. But the leading coefficient is not a 1, it's a 2. So this is the quote-unquote harder or more fun variety. Now, the fact that 2 is prime makes it a relatively easier one of the harder variety because it can only factor as a 2x and an x. So we're going to do this by trial and error. 15 can factor in a couple of ways. 1 and 15, 15 and 1, 3 and 5, 5 and 3. If I'm going to be trying out those four scenarios, I'm probably going to stay away from the 1 and the 15 first because that's going to be making my numbers very, very extremely different. So I'm probably going to try like the 3-5 combo and the 5-3 combo. All right. Now, how do we know what's going to work? We look for the inner product and the outer product, and we want the sum or the difference of those numbers to be a 7. If I can get those numbers to add or subtract to give me a 7, I've got it. So on the inside, I'll have a 3. On the outside, I have a 10. What's 10 minus 3? 7. So it looks like I got the right numbers right away. If you want to verify the others don't work, that would give you a 5 there and a 6 there. 5 plus 6 is 11. 5 minus 6 is negative 1. Neither one of those is a 7. So it's not going to be the 5-3 combo. I'll X that out. So it's going to be a 2x and a 3 and an x and a 5. And then you can come back and get the sign separately if you want. I know that the negative in the middle comes from the sum of the inner and the outer. So the larger product has to be negative. Now, whenever your leading coefficient is 1, you can't just put it in front of the larger number. You have to look at the products. This product gives you a 3, and this product here gives you a 10. Which one's bigger, 10 or 3? 10. So to make the product of 10 negative, I need to make the 5 negative, which means that the 3 is positive. And now if you want to FOIL it out in earnest and combine middle terms, you'll see that it does in fact equal 2x squared minus 7x minus 15. So there you go. Now, of course, it could also be written like this, x minus 5 times 2x plus 3, right? What property allows us to write it either way? Commutative. Good. Commutative. The commutative property allows us to flip those factors around. Okay. Any questions on the warm-up? Are you warm? Hot diggity dog, I'm warm. All right, so 8.3. 8.3 is factoring polynomials. Some of it's going to be a review. Some of it we're going to be using what we talked about yesterday and just now. But there's 3 new things that we're learning today. 3 new things that we're learning today. The first one is going to be multiple steps. We got to get used to having multiple steps. So our warm-up was just a single step. We factored it and we were done. But today we're going to get used to factoring it and then reassessing, and then maybe factoring another time with part of it, and then reassessing, and maybe even factoring again, right? Multiple steps. So get used to multiple steps. The next thing we're going to look at is we're going to look at how to factor when we have quadratic forms. If I can spell quadratic. Quadratic forms. Things that are not x squared and x to the first, but they look similar. And then the third thing we're going to look at the end is the sum or the difference of cubes. Okay? And that's going to be by formula only. All right, so if we go through this little list right here, remember our goal to get to an irreducible factor is either of the form a constant, mx plus b, if you want to write it like that, a linear, and then a cx squared plus d. That's your irreducible sum of 2 squares. Any combinations of those, a constant, a linear factor, or a sum of 2 squares. That's an irreducible prime, okay? This is what we call prime or irreducible. Now, once you get it in standard form, your goal is to get, we'll do housekeeping. And you don't always have to, you just want to size it up. Housekeeping, you want it to be in standard form. So you might have to combine like terms. You might have to shuffle some terms around. But once it's in standard form, what's the first thing that we always do? Never not first. Look for a common factor. You might not always have one. Maybe it's only 1 times out of 5 that you look for a common factor that you actually have a common factor. But if you don't factor it out and you miss it, it's going to make the rest of the problem so much more difficult. So here's a quick little example. You pull out a common factor, you get 2x times 3x minus 5. And we know we're done because we have a linear factor times a linear factor, and you're done. X to the first, you know you're done, okay? All right, next one, difference of squares. Go ahead and cover up the right-hand side of the problem. Let's just look at 4x squared minus 25. I'll kind of walk you through the example a little bit. Whenever you have it with an x term missing, and you only have 2 terms, and it's a minus sign, that's what's important, that this is a minus sign. It might be a difference of 2 perfect what? Squares, a difference of 2 perfect squares. So that would factor into the product of 2 factors. One of them's plus, one of them's minus. You remember what we call these factors when they only differ by plus or minus? I heard it. Conjugates. They're conjugates of each other. All you have to do to figure out what it is you take the square root of the first one. What's the square root of 4x squared? 2x. So 2x goes in the front. And then you take the square root of 25, which is 5. So there it is. It's 2x plus 5, 2x minus 5. And then you would look at those. Are those prime? It's x to the first and x to the first. They're the form mx plus b. So yeah, those are prime factors. Anytime you get down to linear factors, you're done. Okay? Now, let's review right here. What if, another example, what if it were 4x squared plus 25? Would we be able to factor that? No. This is what we call your prime irreducible quadratic. This is a sum of 2 squares. The sum of 2 squares is not factorable. The difference of 2 squares, yes. The sum of 2 squares, no. It's prime. Okay. This one here, I'm going to come back to. We're going to come back to this. Hold off on this. Let's look at this one right here. This is a factorable quadratic. This is, of course, the easy variety, where the leading coefficient is 1. This one double bubbles, and it's just an x and an x, and factors of negative 12 that add up to negative 4. 2 and 6, yeah, negative 6 and positive 2. We like factorable quadratic trinomials because it's just double bubble. Target product, target sum. And this is the easy variety. Then we have the, if you slide over, we have the harder variety. I'm not going to say it's hard, but it's harder because you have a leading coefficient that is not 1. This is kind of like the warm-up. I'm not going to go through this one again, but the answer is right here. 3x plus 2 times x minus 3. 3 is prime, so you know it's going to be a 3x and an x. And then you just look for combinations of 6. 6, 1, 1, 6, 2, 3, 3, 2. And it turns out to be the 2, 3 combo. So you try at most 4 things, right? And you get down to your answer. So this is going to be like the warm-up. Okay. Now let's move down to here. Here's your first new thing of the day. Here's your first new thing of the day. We're going to factor a trinomial in quadratic form. So zoom in on the left-hand side of this one. You got x to the 4th minus 7x squared plus 12. It's a trinomial. We like trinomials. They factor into the double bubble variety. But it's not x squared minus 7x plus 12. It's x to the 4th minus 7x squared plus 12. So how does that change things? Well, let's come off to the side over here. Let's come off to the side over here. If that were, in fact, just x squared minus 7x plus 12, would we be able to factor that one? Well, let's see. I know because it's x squared, it's going to be an x in the front and x in the front. Factors of 12 that add up to negative 7. How about negative 4 and negative 3? Negative 4 and negative 3? Those add to give you negative 7. They multiply to give you 12. Okay? Now, how is it that I can take that form and make it match this form over here? Okay? Well, here's the deal. This is x squared, and that's x to the 1st. If you compare these two exponents right there, The larger one is twice the smaller one. The larger is twice the smaller. That's the form that we're going to be looking for. Anytime your larger exponent is double the smaller exponent, it could possibly factor into a quadratic double bubble form. Okay? Let's see if this one qualifies. I have x to the fourth and x to the second. Isn't 4 twice 2? Yeah, 4 is twice 2. So it could work. So this could easily factor possibly as another double bubble. And to get the numbers, it's still going to be -4, -3. That's not going to change. That analysis doesn't change. Factors of 12 that add up to -7. The only difference is, instead of putting an x in the front, we're going to put a, guess what? X squared. You always put the smaller one, the x that has the smaller exponent is the one that goes in there. Like over here, the middle term was x to the first, so we put x to the first in there. X to the first, x to the first, x to the first. Over here we have x squared, so these become x squareds. Now notice you can clearly see if you were to FOIL it out by doing the first, what is x squared times x squared? X to the fourth, right? And then you do the inner and outer, -4x squared, -3x squared, that's -7x squared, and then you get +12. So as long as the bigger one is twice the smaller, you can factor it using double bubble. You're just going to use the smaller x variable in the front instead of plain old x, okay? Now, this brings up the second part of today, which is the first thing that I mentioned up here. We might have to do multiple steps. Because I'm still staring at quadratics, remember, quadratics may not be completely prime yet. So we have to analyze each one separately. So if we look at x squared minus 4, is there anything we could do with x squared minus 4? You're going to have to recognize it. It's squared, and it's a minus sign again. So what does that mean? It's a difference of two perfect squares. So that's going to factor into the product of two what jigates? Conjugates, yeah. And let's see, the square root of x squared is x. The square root of 4 is 2. So that's x plus 2, x minus 2. Now, is x squared minus 3 a difference of squares? It's not a difference of two perfect squares, right? 3 is not a perfect square. So you're not going to be expected to factor a difference of two things that aren't perfect squares. Okay? In Algebra 2, we don't factor things that are not difference of non-perfect squares. In pre-cal, we would. In pre-cal, we say x squared minus 3 is equal to x minus the square root of 3 times x plus the square root of 3. Okay? It doesn't have to be a perfect square. We could just say, oh, it's the square root of that number. Okay? But we're not going to have to do this. This is a pre-cal thing only, and you're going to be able to stop right here. If it's not two perfect squares, you're done. Okay? So that was a two-step kind of dude. Let's look at the next one over here. Cover up the right-hand side and just look at the left-hand side. X to the 6 minus 4x cubed minus 5. That's a trinomial, isn't it? We love to factor trinomials into double bubble things. But it's not x squared and it's not x to the first, is it? It's x to the 6th and x to the 3rd. So all you got to do is look. Is the larger one twice the smaller one? Yes, 6 is twice 3. So it could possibly factor in that quadratic form. Now let's do the x part first. What's going to go in the front there? X to the 6th or x to the 3rd? X to the 3rd. So we put x to the 3rd, x to the 3rd, and then the rest of the analysis is the same as we've always done. What are the factors of -5 that add up to -4?
Positive 1. Oh no. Positive 5, -1.
Positive 5 and -1? That gives you a 5x on the inside and a -1 on the outside. That gives you a positive 4x cubed. I want it to be a negative 4x cubed. So guess what? -5 positive 1. There you go. Now if you FOIL it out, your first is x cubed times x cubed. That's x to the 6th. Your inside is -5x. Your outside is plus x. That's going to be negative 4x cubed, and then your last is negative 5. Okay, now we reassess. It's going to turn out, and I'm not going to do this right now, but it's going to turn out that this right here will factor into something else. X cubed plus 1 is actually a sum of two cubes. But I'm not going to teach you that just yet. Right now, I want you to focus on, hey, I have the quadratic form down, and once I factor that, I can reassess and go from there. But I'm not going to teach you sum of two cubes just yet, okay? So that takes care of quadratic forms. Any question on quadratic forms? The larger exponent is twice the smaller exponent, or the smaller exponent is half the larger. Doesn't matter how you look at it. It could factor into the smaller one plus or minus a number. Okay, the next one is one that you're used to, factoring by grouping. Let's do this one together. We don't just jump in and put the double bubbles, do we? We always look for what first? Common factor. Is there a common factor other than 1 or negative 1? No, I don't see one. Now, when we put the grouping symbols today, we have to be careful because that's a minus sign. So that grouping symbol, the third one, has to be outside of the negative, and then we squeeze a plus sign in between there. If you put that third grouping symbol, if you put it right here, now it's wrong because now you're only factoring the negative out of that first one. So it has to be outside. The grouping symbol's outside, the negative's on the inside, however you want to look at it. And then we put a plus sign in between there. Okay, now let's factor. We look for common factors. So in the first group of 2, I pull out an x squared, and that leaves me an x minus 4. If you remember how factor by grouping works, that binomial factor that we generate right there, that should show up in the next group, right? When I factor out my common factor, I should get something times x minus 4. Now, here's a new strategy. You have a negative leading coefficient. Negative leading coefficient, you're going to want to factor it out as well. So don't just factor out a 3, which is the common factor. Factor out a what? A negative 3, okay? Factor out the negative 3. When you factor out the negative 3, it changes the sign of both of those, and you get x minus 4. Is that the x minus 4 we were looking for? It sure is. Okay. Now all we got to do is factor out the x minus 4 without a highlighter. Stupid highlighter. X minus 4. And then look right here. In this first term, when the x minus 4 is gone, what are we left with? We're left with x squared. Minus. In the second term, when the x minus 4 is gone, we're left with 3. And then we reassess. I see the linear x minus 4, so I know that one's done. But I still see this x squared minus 3. Does that factor anymore? Is that a difference of 2 perfect squares? No. Does it factor in pre-calc? Yeah, it does, but not in here. We're not going to use radical x minus radical 3, x plus radical 3. We'll just say it's not a perfect square, so we're done. Okay? All right, let's look at the sum. So we've covered the first 2 already. Multiple steps, always looking to see if your result can factor further. We looked at quadratic forms. We saw 2 examples. Now let's look at the sum or difference of 2 cubes. Okay? This is the formula chart that you're going to have on your quiz next Tuesday. Tomorrow you work on 8.3 in class. Monday we review 8.1 to 8.3. Remember 8.1 and 8.2 we covered last semester. So we got to review 8.1 to 8.2. And then Tuesday you quiz 8.1 to 8.3. Okay? So this is the formula chart that you'll have on Tuesday. The difference of squares, it has over there, a squared minus b squared. I want to add this today. I'm not going to add this to the official one, but I want to just remind you today, in contrast, that the sum of the 2 squares, which is a squared plus b squared, is prime. It doesn't factor. It's irreducible. Okay? Now, the reason I want to have that in there is because I want to contrast that with the sum of 2 cubes. The sum of 2 cubes, unlike the sum of 2 squares, is factorable. And the difference of 2 cubes, like the difference of 2 squares, is also factorable. So you can't factor a sum of 2 squares, but you can factor the sum of 2 cubes. Now, here are the formulas. You don't have to memorize them. You just have to know how to use them. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. Okay, good. The key component to factoring by using the sum or the difference of two cubes is identifying your A and your B. If you can clearly identify your A and your B, then it's just a matter of dropping them into this formula, okay? So let's come back up here to this x plus 1, x cubed plus 1. I said it was the sum of two cubes. Let's draw a line here and look at it by itself, x cubed plus 1. Notice it's two terms, and it's an x cubed. This is the sum of two cubes. So here's what the formula, if you go to the formula, and I'll write it up here so you can see it right in front of you. If you go to the formula to the sum of two cubes, you're going to see a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. I need to find what a and b are. So here's what I need to do. I need to be able to write x cubed plus 1 as something cubed plus something cubed. That's my goal. Can I write it as something cubed plus something cubed? Well, let's see. I can write x cubed as parentheses x cubed. Would that be true? Yeah, x to the third power is x cubed. Yeah. Now, what could I do with the 1? Could I just put a 1 in there? What's 1 cubed? It's also 1, right? 1 times 1 times 1 is just 1. So there it is. X cubed plus 1 is the same as quantity x cubed plus quantity 1 cubed. That means that this is my A and this is my B. If you want to write it like this, A is X and B is 1. A is X and B is 1. If I can write it in that form, something cubed plus something cubed, then I've got my A and B. Now it's just a matter of dropping in. So here we go. X cubed plus 1 should equal what? What's A plus B when A is X and B is 1? X plus 1, right? X plus 1. Okay, perfect. Parentheses. What's A squared when A is X? X squared. Good. Minus A times B. That's just their product. What's X times 1? Just X. Good. Just X. Plus B squared. What's B squared when B is 1? That's 1 squared, which is 1. Yeah, there you go. So that's how you factor it using the formula. Now, because the formula always gives you a quadratic trinomial, what you want to do now is you want to at least consider this. You want to consider factoring this quadratic trinomial that's left over. But are there any factors of 1 that add up to negative 1? Any factors of 1 that add up to negative 1? No. So this one actually ends up being non-factorable. Okay? So more times than not, when you're being tested on the sum or the difference of two cubes, that quadratic will not factor anymore, but there's a slight chance that it might continue on. It might double bubble into something. So you at least want to give it a look, okay? Don't just take it for granted that when you do the cube, sum or difference of cubes, you're done. More than often you're not, okay? That's the sum of two cubes. Let's do another example right here. Let me make one up, okay? 8x cubed minus 27. 8x cubed minus 27. That's written in standard form. It's descending order of degree. Are there any common factors other than 1 or negative 1? No common factors other than 1 or negative 1. So is this a difference of two cubes? Well, I know it's two terms. I know there's a minus sign, and I see an x cubed. So it could be a difference of two cubes. I need to be able to write this as something cubed minus something cubed. Okay? So all you got to do is take the cube root of each term. What's the cube root of 8x cubed? 2x. Yeah, you're going to get used to seeing common cubes. 8 is a perfect cube. The cube root of 8 is 2. So the cube root of 8x cubed is 2x quantity cubed. And 27 is also a perfect cube. What's the cube root of 27? 3. Yeah. So that means A must be 2x and B must be 3. So if we go to the formula chart and we look up A cubed minus B cubed, you're going to see the following formula. A minus B times A squared plus AB plus B squared. And now all you got to do is carefully drop it in. So we're going to get 8x cubed minus 27 equals, what's a minus b? It should be 2x for a minus 3 for b. Yes, yes? So 2x minus 3? All right, now here's where you got to be a little careful. A squared. What's a squared when a is 2x? What's 2x squared? The quantity squared. 2x quantity squared. 4x squared. Yeah, you got to square not just the x, you got to square the number as well. So when a is 2x, 2x quantity squared is 2x times 2x, so it's 4x squared. Plus, what's a times b? What's 2x times 3? 6x. Yep, 6x. Plus b squared. What's b squared when b is 3? 9. It's 3 squared, which is 9. There you go. And now, of course, you consider this. Does that factor anymore? 4x squared plus 6x plus 9? I don't think it does. Because if I do the 9 times 4, that's 36. I don't think any factors of 36 add up to 6. Okay, so it doesn't factor. We considered it, but it doesn't factor. So we're done right there. So that's the difference of two cubes, all right? So the sum of two cubes and the difference of two cubes. So we've seen an example, two examples of each of the new types. Quadratic forms and sum or difference of two cubes. All right, let's try out the examples now down here. Example 1, factor the polynomials completely. So unlike yesterday where it told us how to factor, this one just tells us to factor. We have to figure out how. So step 1, housekeeping. Is it written in standard form, descending order of degree? It is, yeah. What's step 1? Always. Look for a common factor. I know that 4 and 108 are both even numbers, so I know I can at least factor out a 2. Can I factor out anything greater than a 2? Is 4 a factor of 108? I think so. If you're not sure, come off to the side. 108 divided by 4. 4 goes into 10 twice. That's 8. Leaves 2. Bring down the 8. It goes in 7 times. So yeah, it goes in 27 times. So before you start looking at a sum of two cubes, we're going to factor out the 4, and that gives us x cubed plus 27. Are we done since we did one thing? Are we done since we did one thing? No. No, we always consider. Until we get it down to linears, constants, or irreducible quadratics, the sum of two squares, we consider keep going. X cubed plus 27. This is what's brand new today, so this is where you need to really keenly be aware. Is that a sum of two cubes? Could it be? It's two terms. There's a plus sign, and x is cubed. So it could be a sum of two cubes. Can I write it as something cubed plus something cubed? That's the question. Well, I think that x cubed could be x cubed, like that. And what's the cube root of 27? We've already seen it. It's 3, right? So a is x and b is 3. So if you go to your formula chart, you're going to look up a cubed plus b cubed, and you're going to see a plus b times a squared minus ab plus b squared. And since you have your a and b identified, don't forget to bring down the 4. Don't forget to bring down the 4. What's your a plus b going to be? When a is x and b is 3, a plus b is just x plus 3. Yeah. And then the next part, a squared minus ab plus b squared. A squared is really x squared minus the product. X times 3 is 3x plus b squared when b is 3 is 9. Yeah. Now, of course, you look at this right here. You consider it. You consider factoring. But are there any factors of 9 that add up to 3? 9 and 1 and 3 and 3. None of those add up to 3, do they? So this one doesn't factor. So are we done? We're done. We had a 3-line problem. It took 3 whole steps. Common factor, and then a sum of two cubes. The more you do, the more fun it gets because you get good at it. And factoring is kind of fun, like little bitty puzzles to figure out. Okay. Letter B. X to the fourth plus 5x squared minus 36. It's written in standard form, descending order. Are there any common factors?
No.
Nope, I don't see any common factors. It's a trinomial. Oh, we love to factor trinomials into double bubbles. We love to factor trinomials into double bubbles. But it's not x squared and it's not x to the first. Is it a quadratic form at least? Here's a 2 and here's a 4, and it appears that the larger one, 4, is twice the smaller one, 2. So it could work. It could work. And if it does work, what's going to be in the front there? X to the fourth or x squared? X squared and x squared. Here's what's really going to make or break it. Are there any factors of negative 36 that add up to positive 5? 9 and 4. Yeah. Which one is going to be positive if the sum has to be positive? The bigger one, which is the 9, and we get the minus. Good. Are we done? Nope. We take a quick break, breaks over, and we reassess. X squared plus 9. That is the sum of two squares. Does the sum of two squares factor? The sum of two squares is what? Prime. So this one doesn't factor. This one's prime. But this one here is a difference of two squares. Does it factor? It does factor. Okay, so I'm going to bring down the x squared plus 9. That's one of my factors. And then I'm going to double bubble the x squared minus 4. One of them's plus and one of them's minus. And it's going to be x plus 2 and x minus 2. What do we call those again in relation to each other? Conjugates. Good. And now we're done. We have two linear factors. Anytime you get down to linear, you're done. And we have an irreducible sum of two squares, so we're done. That's it. That's the prime factorization of that fourth degree polynomial. We did it. Another, well, this was only 2 steps. Previous one was 3 steps. Yeah. All right, comments or questions on that one? Comments, questions, comments? Not so bad? All right. Holy Jehoshaphat. Look at that one. What's the most noticeable thing about that one when you see it? Oh, do you notice the common factor first?
Yeah.
Oh, nice. Let's factor out the common factor. What's the common factor? 3. Good. Yeah. You might notice that right away. That's cool. So if I factor out the 3 all the way across, I get 2x cubed minus x squared minus 8x plus 4. What would be the next thing you would notice about the inside part that relates to how we would go about factoring it? It's got 4 terms, doesn't it? How do we try to factor 4 terms algebraically? Grouping it. Yep. Factor by grouping. Now, don't let the 3 get in your way when you're factoring by grouping. There's going to be a lot of parentheses, and I don't want you to let it get in your way. So right now, let's just use a different flavor, and we'll concentrate on grouping. And remember to keep your negative inside the parenthesis on that third grouping symbol, and then stick a plus sign in between there. Forget about the 3 for just a second. If I pull out a common factor of here, I get x squared times x minus what? Or 2x minus what? What do we get when we factor something out of itself?
1.
We get a 1. Some people still want to put 0. Some people in third period, when they were practicing on their own, put 0. Remember, that's a placeholder. And again, if factoring by grouping is going to work, we're hoping a 2x minus 1 shows up in the next iteration. Now, because this is negative, what should I factor out of the second grouping? Good. Not just a 4, but a negative 4. And that gives us a 2x minus 1. Ah, there's that 2x minus 1 we were hoping for. Okay, now I can factor the 2x minus 1 out. And what am I left with in the first term? X squared. What am I left with in the second term? Negative 4. And I'm tired, so I must be done, right? No. Just because you're tired doesn't mean you're done. I still have a quadratic factor there, so I need to see if I can work on that anymore. That's a difference of 2 squares. Does that go any further? A difference of squares does. A sum of two squares would be done. So 2x, whoa, highlighter time. 2x minus 1 gets rewritten, and then this gets multiplied into x plus 2, x minus 2. The product of two what you gets? Conjugate pairs. Yeah, conjugates. Good. And now I have three linear factors. So with three linear factors, I'm 100% confident I'm done. Yeah. Oh. I just burned myself. That hadn't happened to me at all today. But it's late in the day and I'm getting careless. Remember I told you don't let the three get in your way as you go down? Yeah. You can't forget about it at the end. So you can't just bring it back down at the end like that because every line needs to be equivalent to the one above and below. So I can put a 3 right there, but on this step right here, I need to keep those extra set of parentheses because I don't have that middle. This step is not factored yet. So because that line is not completely factored, I need to add parentheses. But after that, it's factored. You can just put the 3 out front. Thank you, Emerson. I almost missed this problem. I run the first 26 miles of the marathon, but that last point two, that's where I get distracted. There's a sign near the finish line that says free beer, and it points that way, and you're like, oh, okay. And you don't run through the tape at the end of the race. Yeah. All right. Any questions then? Now we're done. We got it down to linear factors and a constant multiple. Yeah. 3 is a constant multiple. All right. Let's go to example 2. The whole reason that we learned a factor is so that we can solve equations. So now it says to solve the equation by factoring. Step 1 is a little bit of housekeeping. In order to factor it, I need to get it in standard form on one side, and it needs to be equal to 0. So that's my first step. Do a little housekeeping. Get it in standard form and set it equal to 0. So I'm going to bring this 12x squared across, and I'm going to write it in descending order. 2x to the 4th minus 10x to the 3rd minus 12x squared. That's the smaller one, and that equals 0. That's step 1. Step 2, now we can factor the left side. Factor the left side. That's where everything's at. And what's the first rule of factoring? Panic? Nope. Look for a common factor. What's the common factor in those three terms? 2x squared. Yeah. That leaves us an x squared minus 5x minus 6. And don't forget that it's still equal to 0. Now, the x squared doesn't factor anymore. X squared doesn't factor anymore because it's just a single factor. But there's a 3-term factor, and it's a quadratic trinomial. So perhaps that one double bubbles. Let's see if it does. Double bubble, right? It would be an easy variety. X squared becomes x. And then are there any factors of -6 that add up to -5? The 3 and 2 might work. -3 minus 2 adds up to -5, but it gives you a product of +6, not -6. So instead of the 3-2 combo, it's actually the 6-1 combo. Yeah, -6, +1. All right. Once you have that side factored, step 3 is to set each factor equal to 0 and solve. Set each factor equal to 0 and solve. So we're going to get 2x squared equals 0, x minus 6 equals 0, and x plus 1 equals 0. You set each factor equal to 0. That's the 0 product property. Now, when you solve 2x squared equals 0, you divide by 2, and then you take the square root, and you get x equals 0. That's the solution that most people actually forget. He never shows up, because when you see 2x squared, you don't see parentheses. Now, the next one, when you add 6 to both sides, you get x equals 6. And over here, when you subtract 1 from both sides, you get x equals -1. I don't care if you skip this step and you go straight from this line to this line. If you're able to do that, I mentioned earlier in the year you could do that. If x minus 6 is a factor, then x equals 6 is the root. If x plus 1 is the factor, then x equals -1 is the root. But don't forget plain old x squared. It's going to generate a factor of 0 every time. whether it's x to the first, x to the second, x to the third. If you have just a factor of x out front, you're going to generate a zero factor. Now, if you want to write those in roster notation, which is typically what the quizzes have you do, you would put x epsilon, and then you put the open brace, 0, 6, -1. You can have these listed now in any order. But that's roster notation. Just to review that. Okay, multiple steps, right? Multiple steps. 1, 2, 3, 4, 5 steps there. 6 if you count the roster notation. All right, questions so far? Last one. The volume of a rectangular prism is modeled by the function v of x. V is for volume. Notice it's a cubic polynomial and it has 4 terms. It's graphed down below. Identify the values of x for which the function is 0 and then write out the factors of v of x. Okay, so what we're doing is we're setting v of x equal to 0. Let's go ahead and try that over here. X cubed minus 8x squared plus 19x minus 12, and I set it equal to 0. Maybe I can find the solutions algebraically. If I'm going to find the solutions algebraically, I want to factor that. Are there any common factors? Nope. But because there's 4 terms, what would be our strategy? Grouping. Let's group the first 2 together, and we'll group the second 2 together, and we'll put a plus sign in between there. In the first set, I factor out an x squared, and that gives me x minus 8. And in the second set, I factor out what do we factor on? Do you see anything common? No. I definitely don't think I'm going to get an x minus 8 out of it. So guess what? Grouping fails us here. Does factoring by grouping always work? Apparently no. Oh, okay. Grouping doesn't always work. So how in the world am I supposed to find the x-intercepts of this graph if I can't do it by factoring algebraically? Oh, I can find the x-intercepts of the graph by looking at the graph. Here's one of them. Here's another of them. There's the third one. Now, I can probably tell that it's at 1, 3, and 4, but I want to make sure from the table. I want to know where the y values are equal to 0. These are my x-intercepts, remember. These are my roots. These are my zeros. These are my solutions. What x values do they correspond with? 1, 3, and 4. So those are your solution sets. X would be epsilon 1, 3, and 4. That answers the first part of it. But if it tells us to find a factored version of v of x, and I can't factor it by grouping, is there a way to write the factors if we know what the roots are? Yeah, it is. This is a review question. Let's see if you remember. If 1 is a root, what's the corresponding factor? X minus 1. Fantastic. And if 3 is a root, what's the corresponding factor? X minus 3. And if 4 is a root, what's the corresponding factor? X minus 4. Yeah. If A is a root, X minus A is the factor. Now, there's one last thing to consider. The last thing to consider is, what is the leading coefficient? Okay? To get the leading coefficient, all you got to do is come up here to the top and look at whatever the leading coefficient is. What's the leading coefficient up here? It's implied to be a 1, so guess what it is down here? It's a 1, which we don't even have to write it, but I'll go ahead and write it just so you see that it's there, and we're done. That's it. So we can't always factor it algebraically, but sometimes if we have the graph and we know what we're looking for, the x-intercepts, remember, are the roots. And if you know a root, x minus that number is a factor. That's pretty cool. So we were able to factor v of x and find the roots based upon the graph in the table. Okay, That's it. How much time have we got left here? 3 minutes? Okay, that's perfect timing. So tomorrow, all day in class, you'll have the period to work on 8.3. That homework will be due on Monday at 9 a.m. And then Monday we'll review 8.1 to 8.3, and then we'll quiz on Tuesday. Sound good? Sound good. Okay. All right.